everyone. Today we're going to start talking about radians and how to convert from radians to degrees, as well as finding coterminal angles in radians as well. So I already wrote the definition up here, so you wouldn't have to watch me write it out. But a radian is an angle made at the center of a circle by an arc whose length is equal to the radius of the circle. So if you remember back from geometry, the radius of the circle goes from the center to a point on the edge of the circle, okay? So you can see here, this is marked R for radius. If I was to take that radius, or the length of the radius, and lie it against the circle here, that would create then 1 radian. So this angle measurement here is 1 radian. And I have a nice website that I think does a better job of showing this and kind of illustrating it. So I'm going to pull that up. It's just on mathisfun.com. So if you want, you can always copy this address here too to look at it. So here it says a radian is the angle made when the radius is wrapped around the circle. So the length equals R. Now a radian is about 57.295 degrees. And here's a nice video. So it'll take that radius and wraps it along the edge of the circle, and that then creates 1 radian. Now it says, let us see why 1 radian is equal to 57.2958 degrees. So if you took that radian from before and actually went to see how many times it fits within half a circle, it looks like it's just a little over 3, or 3.1416. And I'll show the video here too. So it takes that radian, so 2, 3, and then just a little bit more. So that's pi radians. And we know that half a circle, or that straight line, if I measured the angle created, it would be 180 degrees. So in half a circle, there are pi radians, which are also equal to 180 degrees. And this is going to help us a lot when we are converting between radians and degrees. Now, I want you to think for a minute, if there's pi radians in half a circle, how many radians would be in a full circle? You might have guessed 2 pi, and that's correct. Also, going back to your geometry days, when you had to measure the circumference of a circle, the formula we use is 2 pi r. So the 2 pi stands for the entire length around the circle, and then the radius r has to deal with the radius of that particular circle. So I'm going to go over this in the notes as well. But again, like I said, this website I really like because it explains then also how to convert from radians to degrees as well. So to go from radians to degrees, we multiply by 180 divided by pi. And then degrees to radians, we multiply by pi over 180. So here again, it talks about how many radians in a full circle, and there are 2 pi. And then lastly, it just says radians preferred by mathematicians. So our system of degrees was actually made up by humans, whereas radians is used a little bit more, what's the word I'm looking for? All over the place. So radians is going to be the preferred method because more people understand radians versus degrees. And it says because the radian is based on the pure idea of the radius being laid along the circumference. It often gives simple and natural results when used in mathematics. Okay, so now we're going to talk about how to convert between degrees and radians. So if I want to go from degrees to radians, I'm going to multiply by pi over 180. Whatever you want your answer in, that's what should go in the numerator. So since I want my answer in terms of radians, I want pi in the numerator, 180 or degrees in the denominator. Likewise, if I want to go from radians to degrees, then I'm going to multiply by 180 divided by pi, because I want my answer in degrees, so that should go in the numerator. So for example, if I took 45 degrees times pi over 180, I would end up with 45 pi divided by 180. I'm then going to use my calculator to simplify this fraction. So I'm going to pause for just a minute. Okay, so now that I have my calculator, on my calculator, I'm going to do 45 divided by 180, enter. So you'll notice I get a decimal. I want this in fraction form. So I'm just going to go to math, frac, enter, 1/4. So my final answer would be pi over 4. Likewise, if I did 300 degrees, so 300 times pi over 180, I get 300 pi divided by 180. So to simplify that, I go to my calculator, 300 divided by 180. I want to make this a fraction, so math, frac, 5 over 3. So 5 pi divided by 3. Please pause the video, take a minute, and try part C. For part C, you should have gotten 7 pi divided by 6. Now, if I'm going from radians to degrees, so this time I want my answer in degrees, so I'm going to multiply by 180 divided by pi. This way those pi's cancel out because I have 1 in the numerator, 1 in the denominator. So I would just do 9 times 180. So 1,620 divided by 4, because remember we do numerator times numerator, denominator times denominator. So I divide my answer by 4, and I get 405 degrees. Likewise, if I did pi over 6, I multiply by 180 divided by pi. The pi's cancel out, so I'm left with 180 divided by 6, which is 30 degrees. Again, please stop the video, pause for a minute, and try part C. For part C, you should have gotten 120 degrees. Okay, now for graphing these angles in standard positions. So kind of like we did with degrees, I'm going to use some kind of key or reference points. So I start off with 0 pi. I know that a straight line is 180 degrees, or 1 pi. And that means then that 90 degrees, or half of that, would be pi over 2. Then, if I want 1.5 pi, so we had 1/2, 1. Next would be 1.5, or 3 pi over 2. And then finally, a full circle would be 2 pi. So if I want to graph 3 pi over 4, pay attention to the fraction. So it's 3/4 of pi. So if I kind of divide this semicircle up into fourths, so I have 1, 2, 3, 4. If I want 3/4, that would be right here, halfway between quadrant 2. And then my initial side always goes on the x-axis. So it's 3/4 of the way to pi. Likewise, pi, or negative 5 pi over 4. So again, I start with 0 pi, negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. So if I want 5/4, I might break this up into fourths again. So I would have 1, 2, 3, 4, 5/4. And because it's a negative angle, we have clockwise rotation. I'm going to change this last one. Let's change this to 2 pi over 3. So now I want 2/3. So again, I know that this is pi. So if I broke up the semicircle into thirds, I'd have about 1/3, 2/3, 3/3. And if I want 2/3, I'd go 1, 2/3 of the way. So that would be my terminal side, and here's my initial side. Now for our coterminal angles. So remember from Monday and Tuesday, we found coterminal angles by adding or subtracting 360 degrees, because it's angles that have the same initial and terminal side. Well, instead of adding or subtracting 360 degrees, I want to do this in radians. So I'm going to add 2 pi, or subtract 2 pi, because that is equal to 360. So for example, part A below, if I have negative pi over 3, so I'm going to find a positive coterminal angle by adding 2 pi. Now, the thing about adding fractions is I need a common denominator. So I'm going to put this over 1. Because I only have 3 in my denominator so far, that would be my common denominator. So I multiply by 3 over 3, so I end up with negative pi over 3 plus 6 pi over 3. I add those together to get 5 pi over 3. Now for part B, if I have 9 pi over 2, let's find a coterminal angle by subtracting 2 pi this time. So again, I need a common denominator. Currently, I have 2 in my denominator, so I'm going to multiply 2 pi by 2 over 2. So I end up with 9 pi over 2 minus 4 pi over 2. 9 pi minus 4 pi gives me 5 pi over 2, and the denominator stays the same. Now that you've hopefully had an explanation on radians, coterminal angles, I'm going to ask you to do some practice problems.